right. So let's get this train on the tracks. Thank you for attending today. Maybe you've read the agenda, or maybe you just signed up without reading too much. But today we will talk about our way of building a modern data platform on Fabric and how to build it in a scalable and future-proof way, so that you don't really paint yourself in a corner, so that you get started on the right foot and kind of secure future maintainability. So it's a bit more advanced than the basic overview we did last year around this time. But now Fabric has also existed for a year, right? And people actually start building for real. So we thought it was time to give a presentation of how we think you should build for enterprise. But before we get into it, a quick word on us in Random Forest. I mean, most of you know us, right? And we are in 4 different locations around Scandinavia: Stockholm, Gothenburg, Malmö, Aarhus in Denmark. I myself are in the Malmö office, and so is Joachim. He's over there. And 4 other guys. I think Carl Philip is in the call too somewhere. And if you are in the area and want to contact us, our emails are below. But you can also find us in Media Evolution Center, like the office in Västerhamn. Right. But let's get into it. Today's agenda, what we're going to talk about today. Well, I'm going to start with just 5 minutes of some quick feature highlights from Fabcon and from yesterday's update, when a new Fabric blog just dropped. Then most of the presentation is going to go towards the second section here, the modern Lakehouse data platform on Fabric. We're going to talk about what and why, and we're also going to talk about how, which is very important, of course. And then we'll finish off with some DevOps, some tips, methods you can use, and our recommendations, and just a few pointers if we have time on common cases, problems, and capacity management. But kind of the brunt of the presentation is going to be here. Okay. But first, a quick feature highlight from Fabcon and from yesterday to get us excited, right? Because I think this flew kind of under the radar on Fabcon and in all the blog posts and so on. The native execution engine, what's that? Well, for data engineering, I think this was one of the biggest changes that was announced on Fabcon. The whole idea is kind of that Spark, it runs on Java, is written on a Java base, and it's kind of slow, right? What they did is they did some engineering magic, and now kind of with the new Fabric specific execution engine, everything is translated to C++, and it's faster automatically without you having to do anything really. It's 100% free. All you have to do to speed up your jobs by I mean, they could go twice as fast. All you have to do is turn it on in a Fabric environment item. So if you missed this in Fabcon and in the blog updates, please just Google the native execution engine and take a look. Enable it, it's free. Also, a thing that also flew under the radar that we really liked back from Fabcon was the user data functions. They're currently in private preview, so not in public preview yet. But in essence, it's like Azure Functions, but in Fabric. So you will be able to run small snippets of Python code with the click of a button, without having to spin up a whole notebook and wait for a couple of minutes and use a lot of resources for just a small task. They will be reusable and savable to your workspace. And I think they have great potential for lots of small tasks that we don't need a whole cluster for. All right, and some other announcements. They talked about a calculator for capacity usage estimation. I mean, talking to Microsoft, they said this has been hard to do without actual data. And now that Fabric has been running for a while and they have usage data, they can actually build a pretty accurate calculator based on the data they have in the platform. The way it works, it's also in private preview right now, but the way it works is you put in your Power BI users, your loads, etc., and out you get a capacity recommendation and kind of a breakdown. Okay, 20% will be Power BI, 40% will be the loads, etc. The cool stuff. The last little highlight is something that was announced yesterday, or well, the blog post released on the 19th US time. It's 2 new features. So we can now do SQL databases in Fabric, which is basically, it's the normal Azure SQL DB, but it's kind of brought into Fabric. You can access it from the same interface, source control it, and more importantly, like the billing for that database will also go to your Fabric billing. Another thing announced yesterday was AutoML for Fabric data science. I mean, this is a huge selling point for Azure machine learning, and it's great that they've also enabled it for the data science section in Fabric, because it's really been missing. All right. So just a couple of quick feature highlights to get started, but let's get going with the real presentation and the main topic for today. A modern data platform on Fabric. Well, I mean, we see this word thrown around a lot, Lakehouse. And when you open up Fabric and want to build a data solution, like the first choice you are presented with also has that word in it, Lakehouse, warehouse. And we've been in the industry, we've seen this before. But the warehouse is the same as the data warehouse and this Lakehouse and this Lakehouse. Is it the same? I mean, not quite. And there is a confusion of the terminology here on what things really mean. So to get everyone on the same page so that we all know what we're talking about today, let's give you the rundown once and for all, right? So what's really a lakehouse? What's the concept? What does it mean? Well, for that, we need a little history lesson. Back in 2021, it was popularized, I think, by Databricks. They released a paper and a blog post outlining kind of the concept. And their argument was this. Well, the first generations of our data platforms back in the old days, the data warehouses, quote unquote, we did it like this. We took tables, structured data, we ETL'd everything into a central data warehouse, and then the output was usually business intelligence or reports. We all recognize this. It's been done for 20 years, right? But maybe 5 to 10 years ago, I mean, another usage case started creeping in. We kind of machine learning and data science, well, came up out of nowhere, it seems like, in 2015. And it didn't really fit with the existing data warehouses. Because, I mean, if your whole data solution is here, you need to read via ODBC, right? And it's kind of slow. For the data science needs a lot of data usually, and often in a bulk format. So reading it from the data warehouse, that's usually proprietary. By ODBC, it was slow, it wasn't good enough. So what usually happened is they took some data from the warehouse and then they kind of bulk loaded files all the way from a data lake somewhere. But now we have a problem, right? I mean, we've done all the nice ETL over here, right, and cleaned the data and everything. And now they're fetching the files again. So now it's double the work for essentially getting the same data. And the reason is only because like the interface and the connector between the warehouse not fast enough and not good enough for data science. And on the flip side, like the security in the warehouse, we have row level security and table level security. And while security in the data lake is really, really hard, it's just files, right? So the problem was that our data platforms kind of turned into 2 different ecosystems. The BI and the reporting from the data warehouse, and then the data science and the machine learning from the data lake. So they envisioned a third way of doing it, like a future platform, and that was the Lakehouse. And the idea was to unify these 2 systems so that we don't have the split anymore, that we all work towards the same system, right? I mean, they dreamt up, can we get some kind of magic box here that is built on top of the data lake that we can all use and work from? The crux is, well, we need to invent this format. And it was kind of invented at the same time, 2018, 2019, somewhere around that, in 3 different ways. But for Fabric, we use the format called data lake. This is kind of the magic format that solves this, that unifies the 2 systems into one. Because the whole idea is we don't want to lose functionality. I mean, the new system, it uses files in the data lake with a special structure, a special layer. But it's really, really important that we don't lose the old data warehouse functionality, like ACID transactions, create, read, update, delete, maybe time travel. But we also want the new stuff, like streaming, like schema evolution, like efficient reading of bulk data, etc. And it's the format itself combined with kind of the unified approach thinking that is the Lakehouse. It's one system for both reporting, data science, machine learning. So it's removing the split and unifying into one open platform. The question is, well, how do we, I mean, is this possible over just some files in a data lake and some extra metadata? Yes, but this kind of, now we're getting into it, and this leads us on to the next choice that we mentioned earlier between the warehouse and the lakehouse. So if this is the data lake concept, how does it really look like in reality? Well, as I said, it's just files in a data lake in a special format. And a table is one folder under the hood. And the files, they are arranged in a special way with some data files, some logging, etc., etc., etc. I mean, don't get stuck on the details here, but in essence, this is kind of it's the structure that is the format. And it's a recipe. It defines the structure, and then it defines how we should do things if we want to read, insert, update, etc., how we should handle the files. But it is just a recipe. So to be able to actually work with this format, you need to work with the files, and we can't do that manually, right? I mean, we need a computer that reads it, that inserts log, that updates them, and so on and so on. So sure, the format is set with Delta Lake, but we also need some kind of computer that handles the files and actually uses the format. And this is the difference between theory and practice, right? Delta Lake is just a protocol. I mean, it's a recipe. In reality, we need to do something with the recipe. We need to implement the recipe. And this brings us onto the choice in Fabric. This is kind of the crux of it. In Fabric, we have 2 alternatives for working with Data Lake, or the Delta Lake. So we have the warehouse and we have the lakehouse. So if maybe an analogy, so if Delta Lake is the recipe, these are kind of the cooks or the bakers, right? I mean, it just shows us how we should bake the cake, but then we actually need to make it. And these two bakers, they come with different histories from completely different ecosystems. So this is the real choice that we need to make to build a data platform. And for this baker on the left, for the warehouse, it uses the Polaris engine, comes from Synapse SQL, and it's rebuilt for Fabric, but it's built for one language. It's built for SQL. Spark comes from another completely different ecosystem. Comes from Hadoop. It's maybe 10 to 15 years old. And here you can work with multiple languages. But in the end, it's the same engine under the hood. It's just a different way of interacting with it. So they work with the same recipe, the same Delta Lake format as a base. But as they are different bakers, they have kind of different skills. Because there are actual people working on this, right? You need to implement all the potential features. Sure, the protocol defines we can do this and this and this, but we need to actually do it in practice in the compute engine, which means that the features will differ between these two, right? So if we take the engine on the left, the warehouse, Microsoft Polaris, this is great. I mean, it's familiar, it's TSQL. but it's a much newer engine and ecosystem than Spark. So there are no streaming features, there are no machine learning extra features, and we can't really handle any files and images and things like that. It's only built for tables. The engine on the right is, well, it's a much more mature ecosystem, Spark. You can do streaming, it has machine learning features, you can handle files, tables, etc. Which is great, but it comes with a downside. I mean, it's really a collision of two different worlds here, right? We have the old quote unquote, the BI, that's a B. We have the old BI SQL world here on the left. Right, it's hard to write with a mouse. And then we kind of have software engineering here on the right. I mean, there's more code to the right, to the left, it's basically databases and reports. So it's kind of a collision of two worlds that has happened ever since the tech companies and kind of Silicon Valley came into the data world. It used to be on the databases, then Netflix came in, used big data and Spark, and now we're kind of unifying and working towards the same ecosystem. And there's lots of nuances between choosing between these two. I mean, but let's not get into it. I'll make it easy for you. Just pick Spark for an enterprise data platform. Sure, the warehouse is fine to get started and it's familiar. And it can really work if you're a small business or just need to do a batch once a night or once a day and then consume some reports. But eventually, if you're going to keep building on your data platform and taking streaming data, machine learning, etc., work with unstructured data, then you're going to have to rebuild for Spark eventually. Right. So this is the choice for an enterprise data platform because it has more features of the whole data lake concept that we kind of aimed towards in the first place, right? We want to work with unstructured data. We want to work with streaming, etc. But the question, of course, remains now that we made a choice, we know the goals. How do we do it? This is the next section of the presentation. Like which architecture, with method, and more importantly, now that we have decided on Spark and know that we need to write some PySpark, some Spark SQL, how do we avoid making spaghetti code? I mean, SQL, like the warehouse, is more structured. You have procedures, you have views. Well, it's free play in PySpark, right? You have notebooks and you can write any code you want. So I think that is the harder problem. Like the method and building a platform that is maintainable and scalable is kind of the hard part. The architecture it's easy. I'll just leave this here for the recording. It's, well, you do a medallion structure, your whole platform in kind of one workspace, but then you separate out the gold data marts into different workspaces for permission reasons. I mean, but that's easy. The hard part is actually building the platform in a good way. Now we get into our way of doing it. I mean, this is what I'm presenting is not the one truth to rule them all, but this is how we in Random Forest think that you should build your enterprise data platform on Fabric. So that it's maintainable, consistent, error-free, and scalable. And by scalable, I mean by man hours, like not data-wise, because both the warehouse and Spark will scale to large amounts of data. By scalable, I mean kind of the man hours it takes to add new data sources, add new tables, maintain the old pipelines. I mean, because really we are limited. We are small data teams and our time is really expensive. So how do we build something that we can really go a long way with without hiring 10 new people? And the way to do that, based on our experience, is to build a metadata-driven platform. And what the hell is that, you think, if you haven't heard the term before? Well, I think it will have to be a journey. It's not something that you can explain in just one sentence. So let's just keep on going from where we left off. We've decided on Spark. and we start working with lakehouses and notebooks, easy peasy. Sure, we need to load some data, we do a notebook. For another source, we add another notebook, etc., etc., etc. But you're going to end up with this eventually. I mean, it's going to be notebook spaghetti, and like 10 sources and 5 data layers later, 1 notebook for each. You're going to end up with code everywhere, duplicated code that is supposed to do the same thing, but is actually doing 2 different things, bugs, etc. It's easy to start off with just a notebook, but 10 data sources down the line, it turns into something unmaintainable in terms of man hours. Also, many more downsides to using notebooks, kind of in almost transparent text down there, but they are designed for experimentation, data analysis, and they're not really designed for engineering, because we are doing data engineering after all, not data analysis. Right. So what do we do instead? Instead of this mess, we take all our processing logic and we package it into one PySpark package. So, and this is kind of taking a page from software engineering. This is the Silicon Valley world of data engineering kind of leaking into our BI world, right? I mean, all software is packaged for a reason. It applies here too. Like if you package your code, it's modular, you can reuse functions easily, you write things once, you don't repeat yourself, you have a whole overview in one single place. And more importantly, you can actually test your code. Like good luck testing 10 different notebooks. Like if you package your code, you can write automated tests to make sure that your merge statement is working. Like if you have 200 tables in production and you make a changement to some merge statement, I mean, you don't want that breaking. You want to make sure it really works as you think it will. And also, if you package your stuff, you can do change management via your regular Git flow. I mean, looking at Git for 20 different notebooks, really hard. I mean, you have no overview. If you have everything in one place, it's easy to see the changes. Right. So this is kind of the first step. You move away from 10 different notebooks and you take your central processing code and package it, which means you can install this package and you can run it in one single notebook instead of a billion different ones. But of course, we shouldn't. Like we have 10 different sources and we load files from 10 of them. Like, I mean, that shouldn't be 10 different functions. It should be one file loading function, right? So this is the next step to kind of building something scalable. You write generalized functions, a function for loading files, a function for doing a merge and doing a merge SCD1, SCD2, a function for loading from an API, etc. So generalized functions. And then you take kind of the metadata. Well, we should load this file and this table and that table. You move that out of the package and into a metadata database. You separate out kind of the what, when, and how from your general functions. All right. So sure, functions and what, when, and how. But there's one missing piece here for a data platform. We of course need to define how the table should look like transformation, joins, etc. How do we do that? Do we save those in the package? Do we save those in the metadata DB? In files, in like files with views? Well, I mean, the way we do it is the transformations are designed or written as views, and this is something the user writes. Maybe it's a bit unclear just from looking at this. I'll draw a picture. Let's say we need to load a table in silver, right? This is silver. And this is bronze. So we write a view matching our silver table 1-to-1, where we actually define how our silver table should look like. So we can do all the joins we want. We can do the data cleaning, join in surrogate keys, etc., in the single view. And then the package just reads that view and kind of does the work we want it to. So what does this, why do we do this? Like, why do we have generalized code and then separate metadata? And the idea is that we separate the concerns. So we separate the code implementation, like actually how we do, the dynamic merge and kind of how we write things to the databases, from the configuration and metadata. And that is when we should load, what we should load, the parameters, and business logic, like the transformations that we should do. So it's a complete separation of concerns here. And this allows us that, to add new flows, if we've already built a generalized function, we can just add more metadata. To load another file, we add another little metadata row. To load another table, we add a row to the metadata, and then just define a new view for the table. So then, users could potentially do a lot of data loading and a lot of transformations just working with SQL, like doing views, adding rows to the metadata DB. And they don't have to know PySpark because we've already written the general functions once. We have different roles in our teams. And then this lets us focus on, the ones who are really good at PySpark can focus on doing that. The ones who are really good at the business logic and the transformations can focus on doing that. So we can kind of separate the concerns here. All right. So we just define kind of what we should do in the transformations, and then the package picks that up and executes it on Spark, on Fabric. So while we define what we should do in SQL, it's actually, the loads are running and are executed on Spark, which is the compute engine that we really should pick for enterprise. So it's a bit of the best of both worlds here. Great. So that's for the data loading and for the processing logic. I think the final piece of the puzzle is, how do we do orchestration? And the metadata way, it works for that too. We orchestrate with Fabric pipelines, but instead of clicking and building 17 pipelines for 17 different flows and changing, 100 different activities when we need to change a little thing. Instead of doing it that way, because it's not really maintainable, we do it this way instead. We just define the dependencies in the metadata. And instead of manually creating the orchestration pipelines, we take these dependencies, build kind of a dependency graph, and then we generate the pipeline files. You see where I'm getting at here? So if we have all the dependencies in the metadata, we can generate kind of a dependency graph, and then we can kind of build the pipelines programmatically without clicking. So we just walk through the dependency graph, add an item. This is done automatically. 1, 2, 3, bam, bam, bam. And you have a pipeline file, and then you can deploy that to Fabric. So it's less clicking, and it's, again, a metadata-driven approach. We define the dependencies, and instead of clicking through and creating 100 pipelines manually, we just define the essential info and then generate them and deploy them to Fabric. And doing it this way, it's important to have orchestrations as visual pipelines because it allows for an easy overview. Like when we see our loads run, we can see the different activities in the pipeline ticking through. Okay, that worked, crash. And if we need to rerun, we just restart it from here, and then it goes through and it goes through. But so pipelines, sure, but don't click your way through 300 ones, just generate them from the metadata. Okay, cool. So that was our approach. Package your code, split out the metadata, orchestration also from the metadata. I think the problem here is you actually have to build this, right? It's when we start a Fabric project, we buy the capacity, we get started. You can't tell your boss, we need 6 months to do this first to get started on the right foot. So I guess this is where we come in. We've already built it naturally. So what we offer is kind of we can deploy this framework to your environment. We take the code, but deploy it in your environment and kind of do handover and educate you so that you get some solid ground to stand upon. And this is, since it's already built, it can kind of be a quick project to get it deployed and just to do one end-to-end flow to get you started on the right foot. So please use our expertise and use the code base that we have to really get started with a scalable framework for the future. If you're interested, contact Niklas, Gustav, or anyone else from Forest. All right, but that's enough for the upsell. I think we've now gotten through kind of the main brunt of the presentation, and it was a lot. So let's just take a moment. What and why? Well, the goal was the Lakehouse, a unified platform, right? Where both the data warehouse, the reporting, and the machine learning can sit in kind of a single platform. And how? Well, it was not doing a bunch of stuff manually. It was reusing code, keeping the metadata separate, and building for scalability, man-hours wise. So the final two sections here are a bit shorter, but it's important to say something about DevOps too, because it's a big challenge in Fabric. So let's get started with that. Well, it's not easy because we have the base of the base of the whole DevOps foundations is kind of the Fabric API. So you can of course click in the UI in 10 different places, but you can also use the Fabric API to do all the things that you can do by clicking. You can do them programmatically. You can get item information, you can create, read, update items, and you can also start jobs and run jobs. But the problem is this API, like for DevOps, it only supports user credentials. So like I need to sign in with my user to create the pipeline, and my colleague needs to sign in with his user. Okay, so if you want to run something from, well, say, Azure DevOps, which user is that, question mark? I mean, usually you would use a service principal for this. You create a service principal that has credentials kind of for Azure DevOps, a key, and you use that. But it's for most of the API functions, service principals are not supported yet. So this kind of means using Azure DevOps pipelines to call stuff and do stuff with the Fabric API is not really viable, because for the credentials, like before you run a pipeline, you would have to take your own user token and kind of paste it into the pipeline. I mean, there is no long-lived credentials. So this is a huge, huge challenge, and it affects all the different methods we have for DevOps in Fabric. They're working on this. I mean, they're rolling out service principal supports for the different API functions, but it's in development. So it's just a few that are supported now, more to come. All right, but the actual CI/CD, like we see 3 different methods. If you come up with something else, please contact us. So I will show you the 3 methods, and then we will recommend one, because we've tried them all. The first method for CI/CD on Fabric that we see is kind of a Git-centric approach. You use the Git integration to sync all your items in your workspace up to a Git repository, like in Azure DevOps. Right, so you write your dev stuff, you sync, and then for prod, you create a new Fabric workspace, and then you sync from that Git repository instead. I mean, does this work? Could we deploy like this? Well, I mean, it kind of works. It's been a bit buggy, but a huge problem here is that the bound item IDs do not get mapped. I mean, if it looks like this in dev, and we push things to Git, when we sync from Git, like the connections between notebooks and lakehouses, etc., it will still use the IDs that are back in the development workspace. It won't update the IDs to match the new items in the production workspace. So this kind of disqualifies this approach. I mean, because you would have to manually update all the IDs and all the different items already in Git, and that's not really viable. So until this gets fixed, it's not really a way to go. Also, like again, doing this automatically, say via an Azure DevOps pipeline, there's no service principal support, so you would have to do it manually every time. So maybe in the future, and But for now, items do not get mapped, so it's not the way to go. All right, the second approach then. Well, they released Terraform on Fabcon, or at least a preview, so that you can use infrastructure as code together with Fabric. So what about using Terraform for everything? Like you maintain a Terraform project for all your stuff in your development workspace. And when everything looks good, you just swap the target and you deploy it to production instead. Terraform is great. I mean, I've done whole data platform projects this way. But for Fabric specifically, the Terraform provider is very, very new, just a month old or so. So it doesn't support all the items yet. And there are some bugs, etc. And again, it's the same ID mapping problem as earlier. Like you would manually have to map these IDs when you deploy between dev and prod. There's a lot of Terraform code there to be done. And it's also affected by the lack of service principal support because it uses the APIs in the backend. So it could work in the future, but a huge downside from this is that it's a lot of extra work to maintain Terraform project. And if you don't know Terraform, I mean, it's a whole new thing, right? So if you're already using it for a bunch of other stuff, sure, give it a try. But it's a lot of extra development work for not much benefit. There are other easier ways to deploy than doing this. Our recommendation is to use a hybrid approach. You use the built-in Fabric deployment pipelines, right? And they were so-and-so, like half a year ago, but now they support all the items in Fabric and they work really well. And most importantly, they actually map the IDs correctly when you deploy. Give or take a few bugs, but from what we've seen, it works. And if you do our metadata approach, like the package with your processing code, it is deployed in an environment item in Fabric, and this follows along in the deployment pipeline. So you kind of get the working version of your package deployed to production. But there are a few things missing here, sadly. If you want to deploy some views, like you version the views and want to deploy them, well, the deployment pipelines, they do not deploy the tables between lakehouses. So if you have 20 tables in prod, in dev, you create your lakehouses in prod, they will be empty. Which means like all the views that select from your tables, they will suddenly not find your sources. So what you need to do is you need to add a pre-deployment script. And you can just shallow copy your tables so that you actually have the schemas to go on. So now the views will deploy correctly in your pipeline. And then probably a post-deployment script too. Like if the package is deployed for our approach, you want to move the metadata over and then you're done, right? You've deployed your whole solution. Package is moved, items are moved, metadata are moved. So this is a way to go, kind of. It allows you to deploy table schemas. It allows you to deploy all your Fabric's items mapped correctly. And it also allows, well, for some extra deployment of metadata if you do our approach. But what we want to do is, of course, automate this, but it's the same problem here. I mean, adding these 3 steps into a DevOps pipeline, well, again, no service principal support. So for all the 3 alternatives we see for CI/CD, you have to do the deploy. Well, it should say manually for now. I mean, you can't get away from this until you have the service principal support in the Fabric APIs. And like, sure, you can get your user token and paste it into Azure pipelines, but I mean, then you might as well do it manually. And also a challenge with this is keeping the development workspace clean. Like, because it deploys all the items. Like you can't pick, well, these 5 items and these 5 items. It deploys all the items in the workspace. So somehow you have to keep your development workspace clean of all the extra in development stuff that we create when we work. An approach could be having separate kind of one user only development workspaces. So you kind of have a main development workspace, and then you have my experimentation and my colleagues' experimentation workspace, etc. Or you just make sure that people clean up their stuff when they're done. All right, so that's it for DevOps. To reiterate, I mean, the whole Git-centric approach could be great if the items actually did get mapped. Infrastructure as code, sure, if you're an expert in it, but don't do it otherwise. And it's also in preview. Use the deployment pipelines that are built in. I mean, this is kind of where Microsoft is putting in all the development effort. So they have gotten a lot better just over the half year. And eventually you will be able to add the pre-deployment scripts and the post-deployment scripts into one single Azure DevOps pipeline. So this is the approach we would recommend. Right. I'll finish off with some just 3 minutes on some common problems that we've seen over the years and how you can kind of guard yourself towards them. A big problem here is that for the capacity management, we don't really have any limits that we can set. Like we can't say, well, half our capacity should be for development and half should be for production. This is coming in the future, they've said, but it's not supported as of now. What you need to do instead, not to accidentally run out of juice in your production workspace, is to actually split your capacity into 2 different ones. You take your F8 and split it into F4, F4, or maybe you take your F16 and instead you do one F8 and maybe one F4 for development. But you have to split it into different capacities because it's a huge risk, like having your production capacity and your development capacity closely tied together. I mean, sometimes someone is going to do something that kind of stops all your production pipelines, and that's not good. So if we can't set limits, I mean, what do we do? How do we do it? Like, how do we actually know how much we need and how much we use? And the way to do it is that you monitor. And what you need to look for is kind of, you need to schedule all your pipelines, monitor, and then kind of see where it evens off. So as an example, this is a real world example. This was kind of our load. And then we added a couple of pipelines, scheduled them like once an hour. And you can see the load is starting to creep up. And then it evened out right at the top. I mean, unfortunate, but it was the case. And you can see here in the throttling graph, it also kind of started creeping up and then it evened out. So if the throttling, starts creeping up towards the maximum line, you need to do something, either load less or redesign. What you're looking for is kind of a plateau, right? Like here and here. Like do your actual production schedule and wait until it stabilizes, and then you can see how much is actually used. And what you really need to look out for is not the notebooks. I mean, these are fixed. The cluster takes a fixed amount of compute, and if it runs, and it's just going to look like it does over here, just flat. What you really need to watch out for is pipelines, because they scale up and down as they want, and especially with the copy data activities. If you suddenly get a whole bunch of data in the platform that you hadn't planned for, and you have a pipeline doing a copy data on it, maybe to a sink somewhere, saying Dataverse, well, it can add on a bunch of parallel copies and keep scaling, and then it can easily happen like the case we have here. We went from a nice flat usage graph to just adding a few pipelines, and then bam, it scaled out of control. So the notebooks, easy to plan for because kind of the max limit is fixed. The pipelines, be wary, keep track of those. For estimation, I mentioned that the calculator is coming. It's in private preview. We've seen it, but we're not allowed to show it. But I'm going to go out on a limb here and say, like, if you're a small or medium enterprise, maybe once an hour or so, without any Power BI usage, you'll be fine with an F8 or an F16 probably, if you have a normal quote-unquote amount of data. But I mean, Power BI, it adds on a lot of load. if you need to load more frequent or more data, that, well, you need more compute. And if you have multiple environments, you kind of need to split the compute anyways. So watch out for that. So even if like the base rule of thumb is maybe an F8, like you need to add capacity if you have Power BI, load more often, etc., etc. And please don't forget about Power BI usage. It actually takes a lot of capacity when people are clicking in reports and filtering and doing stuff. So if you have a lot of Power BI users, please consider upgrading quite significantly to a larger capacity. Right? But in essence, you kind of have to make a guess and then kind of monitor your actual workload and see. So maybe you start as a pay-as-you-go, see the kind of actual workload, and once you know, you kind of lock in a reservation. Right, just as a final note, another common case is you need to get stuff behind private networks. And I think a lot of people have missed this. Like there is a built-in feature for this. We'll manage private endpoints. It's your best friend. I mean, it's you just go into the workspace settings, you click create, fill in the resource you want to reach. And step 2 is just going into that resource and kind of accepting the connection. Don't fret too much about the private networking stuff. You can come a long way with this and just a data gateway. All right, but now all your startup times increase to 3 minutes. Yeah, but just some side bits. I mean, as a summary, our recommendation is use Spark and Lakehouses if you're going to build an enterprise data platform. And for scalability, maintainability, in terms of man hours, package your code and build using a metadata-driven framework. And we can help you there. Please contact Niklas or Gustav or Carl Philip or me if you're interested. Right, that's it. Lots of information in 40 minutes, but hopefully you have an idea of how you should approach the enterprise scenario. Any questions? I mean, it could be anything Fabric related. How do we do this? How do we do that? Etc. 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 Yeah, thank you, Morten. All right, the chat. Yeah, Christopher, I see you asked about, well, what about data factory for orchestration? Do you have any thoughts? Well, the problem before quote unquote, but the problem is that you can't really run Fabric items from Azure Data Factory. I haven't checked in a while, so maybe they've added integrations. But it's essentially the same thing, right? I mean, but the data factory, it of course has more features like triggers, data sets, and so on. And it has a bit more connectors too. I think data factory is a better solution, like orchestration, but since we're working in Fabric, it will be completely separate building. You will have problems with connections. So I mean, you should really do Fabric pipelines, even if data factory might have some more features. It's Fabric pipelines is the way to go. And now they've added a whole mount thing for so you can mount your whole data factory into Fabric nowadays. It's all moving to Fabric data pipelines. Right. Yeah, the private endpoint and private, it's kind of different things. The private link is for putting data into Fabric, kind of from the outside, but it's a bit iffy. You can also use a private endpoint for that. Like the private, we still haven't really found a use case for the private link. Like all the connections that we have needed to do with the private networking, we have been able to do with the private endpoints. But I think it's kind of a sub feature of the private link, I guess, but like the things you use in reality for us has been the private endpoints. The private link is kind of okay. But I think once you give it a try, it will be apparent. It has worked really well for us so far. And maybe for on-prem, we can mention that, like most of you guys have on-prem data, right? And this, well, it's going to be a It's going to be a data gateway that you install. It's the same one that you use for Power BI. But this is kind of why you want to use Fabric pipelines for orchestration too. Because to be able to read from that gateway, you can't do it with a notebook. You need to do it through a Fabric pipeline. Then you schedule your pipeline for getting the data up into Fabric, and then you continue reading it into your data platform via notebooks and Spark. Right. I think that's it for the questions, right? I mean, how are we doing on time? I guess we can end early if it's not anything else. Joachim, do you have anything you're wondering? Maybe around DBT or anything like that?
No, not really.
Yeah. All right, then let's cut it there. The summary again, use Spark and Lakehouses, package your code, don't do notebook spaghetti, and build a metadata-driven framework. Contact us to do a short project where we deploy the base. All right. Thank you for today. I appreciate your time.